Hello class, welcome to lesson A2, which is all about sequences and equations. By the end of this lesson, you should be able to describe sequences using words and symbols and find terms of arithmetic sequences. All right, so let's talk about some new vocab that we have. So a sequence is an ordered list of numbers, okay? So like an example could be if we looked at a list of numbers that maybe said like 2, 4, 6, 8, and then usually there's dots to show you that the numbers would continue on 2, 4, 6, 8, 10, 12, 14, and so on, okay? Another ordered list could be just 1, 2, 3, 4, 5, and just keep going. So any ordered list of numbers. Term is each number in the sequence. So if we look back at this sequence, this would be my first term, this would be my second term, this would be my third, this would be my fourth, and then so on and so forth. Now an arithmetic sequence, you might read this word and say, but Miss Johnson, that doesn't say arithmetic, that says arithmetic. You're not wrong. Those two words are spelled the same, and so you've maybe heard of arithmetic as another word for math. When that word is paired with the word sequence, we pronounce it arithmetic. So that way we signify the difference between just talking about math or talking about an ordered list of numbers where the difference between the terms is constant. Okay, so like I said earlier, 2, 4, 6, 8, the difference between them is 2, right? I have to add 2 each time. If I were to do a list that was like 1, 2, 4, 7, those aren't changing. It's not changing by the same number each time. So that would not be an example of an arithmetic sequence. Common difference is the constant difference between others. So like up here, it would be adding 2 each time. That would be our constant difference, okay? So that's the vocab that we are going to talk about and use in this section. Now, if I asked you to describe the sequence, and we're looking at the numbers 5, 10, 15, and 20. So this would be my first term, and then 10 would be my second term. Then I would have a third term and a fourth term. My common difference, how much it's changing by, I'm adding 5 each time, right? So I would say common difference, ooh, that was a terrible M. Common difference is 5. And I'm even going to put a plus in front of it. If you want to abbreviate it to CD for this section, you can certainly do that. And you could just say CD and then plus 5. Now, if we look at this next one, my first term would be 6, second term is 7, third term is 8, fourth term is 9, and my common difference is plus 1, right? That's how much it's changing by each time. Now, what if I asked you to find a term? So let's say I want, in this case, the 15th term. So what you could do is keep writing out the numbers, or I'm going to show you a shortcut on how to find a term. That's maybe, what if I asked you to find the 150th term? You wouldn't want to sit there and write out 150 different numbers, right? So I'm going to show you a way that you can do that much faster than having to write out all of the different numbers. So when you're trying to write an equation for this, what you want to start with is find the common difference. So step 1, what is the CD? So in this case, to get from my first term to my second term, I added 3, To get from my second term to my third term, I added 3. To get from my third term to my fourth term, I added 3. So you start by identifying that common difference. And so in this case, our common difference is 3. Your second step is to take your first term and then subtract the common difference. So in this case, our first term is 7, and our common difference is 3. Okay, so that number would be 4. 7 minus 3 is 4. And so then, once you have those two pieces of information, the way you write the equation is you take your common difference, or you would say A of n. That's how we signify that we're dealing with an arithmetic sequence, okay? So instead of putting like y equals, for arithmetic sequences, we do A and then a smaller n down below, okay? So A of n equals, then you take your common difference, and then you put an n with it, and then you say plus whatever this number is. So in this case, 4. So let's test that out. If I look at this problem, and let's say I'm looking at my first term, because I already know my first term should be 7, right? So if I plug in 1 for n, I should end up at 7. So 3 times 1 is 3. 3 plus 4 is 7. And that matched. So I know this equation worked, at least for the first term. What if I try the second term? So I put a 2 where that n is. And then I would have 3 times 2, which is 6. 6 plus 4 is 10. So that matched that one as well. So I know it works. Now, the question is asking me about the 15th term. So I'm going to plug 15 in where there was an n and see what I get. So 3 times 15 is 45. 45 plus 4 is 49. So the 15th term is 49. And my equation was right down here. Okay, so if you can remember those 3 steps, you are good to go. First, start by finding your common difference. So we are changing by 3. Then you do your first term minus your common difference. So 7 minus 3 in this case. That gave us 4. Then you just plug it into your equation. You start with A of n equals common difference times n plus whatever number you got in step 2. Then you can plug in whatever term you want to try to solve for. All right, now for this one, I want you to try to figure out the equation on your own, and then I want you to find the 15th term as well. But right now, I just want you to start with the equation. And then before you do the 15th term, you're going to check back in, okay? So, step 1, find the equation to describe the sequence. Don't forget your 3 steps that we went through in the last example. Good luck. All right, hopefully for your equation, you did the 3 steps. You found the common difference. You said, I am adding 2 each time to get to the next term. So your common difference was 2. And then for the second step, you took your first term, which is 8, minus the common difference. So 8 minus 2 gives us 6. Then you plugged it into the equation. So you said a of n equals 2n, so our common difference times n, plus 6, the number that we got in step 2. Now that you have that equation, I want you to find the 15th term. Good luck. Okay, for the 15th term, I hope you plugged it in like this. You said 2 times 15, which is 30, and then you said 30 plus 6, which is 36. All right, we have one last example to look at together, and then you are free to start your homework. So use the diagram to write an equation. Oops, sorry, that should just say an, not and. Use the diagram to write an equation and then find how many tables are needed to seat 16 people. So this is my first term, right? This would be my second term. This is my third term. The way we know that is how many tables there are. So for my first term, I can seat 4 people. For my second term, I can seat 1, 2, 3, 4, 5, 6 people. And for my third term, I can seat 1, 2, 3, 4, 5, 6, 7, 8 people. So to write an equation, again, those 3 steps, I start by finding my common difference. To go from 4 to 6, I add 2. To go from 6 to 8, I add 2. So my common difference is plus 2. Then, remember, the second step, you take your first term, which is 4, and you subtract your common difference, which is 2. And 4 minus 2 is 2. Third step, you write a of n, so that way we know we're talking about an arithmetic sequence, equals our common difference, so 2 times n, plus the number we got in step 2, which is 2. So that's my equation. And then I want to find out how many tables are needed to seat 16 people. So how many tables is not, how many tables denotes or tells us the term number, right? So our first term has 1 table, our second term has 2 tables, our third term has 3 tables. So if I want to find how many tables, I'm actually trying to figure out what term number it is instead of how many people can sit there. So this time I'm solving for n. So whenever you are given the total, what you're going to do is you're going to say the total, so in this case the total is 16, equals my equation. So in past examples, we were trying to, we were plugging in the term number that we knew, right? This time we're trying to find out what term number that is. So now I'm going to solve this. So I start by moving the number that's not touching the variable to the other side. So I'm going to subtract 2 from both sides. So I have 14 equals 2n. And now I want to move the number that's touching my variable. So 2n is the same as 2 times n. And the way I undo multiplication is with division. So I am going to divide both sides by 2. I'm left with 7 equals n. So that means how many tables are needed? 7 tables. Okay, so most of these questions are 2 parts. They ask for the equation, which we found, and then they ask you to solve either for the term or to solve for, to find out what term it is in the sequence, or to solve for what number falls at like the 200th spot in the list, okay? If you have questions at all, please don't hesitate to ask. I'm more than happy to help you, and I hope you have a great day.